Hello friends, welcome to Abednego Online Math. Today we are looking at physics, and the physics here we are looking at dimensional analysis. If you are writing JAMB, WAEC, NECO, this topic is for you. And this topic is rarely treated by physics teacher. So I'm taking this time to teach you this topic so that you will understand. Dimensional analysis, there's what we call fundamental and derived quantities. Fundamental quantities are those quantities that are independent of themselves. They do not depend on any other quantities for their derivation or for their definition. So they are independent. Example, we have the fundamental quantities like mass, length, and time, amount of a substance. The unit for mass is the kilogram, the unit for time is a second, the unit for length is a meter. Amount of a substance is measured in mole. So we also have luminous intensity measured in candela, and these are the basic fundamental quantities that we have. So every other quantity depends on them for their definition or derivation. So derived quantities are those quantities that depends on fundamental quantities for their derivation, like things like area, because you know that the area of a area is length times breadth. So that was to say length times breadth, area is dependent on length measured in meter and breadth measured in meter to give you meter square. That is the derivation for area. But we are not looking at that. We are trying to look at dimensional analysis. What is this dimensional analysis all about? Dimensional analysis or dimensional units is quite different from derived units. So look at what we are trying to do here. If you're studying JAMB, we know that the three basic fundamental quantities, there are three basics. Is the mass. Mass is measured in kilogram. Sorry for that interruption. We have the mass. And the mass is measured in kilogram, kg. We have the length. Length is measured in meter. We have the time. Time is measured in seconds. So, if you're talking about dimensional analysis now, these three basic fundamental quantities, dimensionally, length, which is mass, which is measured in meter, mass, which is measured in kilogram, is represented by m. Dimensionally, length, which is measured in meter, is represented by L. That's the dimensional symbol. Then time, which is measured in seconds, and represented by S, is dimensionally represented by T. You need to understand what I'm talking about. This is dimensional representation, while these ones are fundamental representation. So dimensionally, look at the way all these three fundamental units are being represented. So if I ask you what is the dimensional unit for area, already you know that your area is the length times the breadth. So if you have that, you're going to have the length is L, in meter, measured in meter, times the breadth is also measured in meter. So for giving you meter square, this is the unit for area. But dimensionally, this is not the unit for area. Dimensionally, m is equals to L times m again is equals to L, giving you L square. So this is what we are talking about. This is the dimensional unit for area. If I say, what is the dimensional unit for velocity? Velocity is displacement over time. So displacement is measured in meter and time is measured in seconds. Time is measured in seconds. That is why from there we say that velocity is equals to measured in meters per second. Meters per what? Second. Or if you don't write it that way, you also see your teachers writing something like this: ms raised to power minus 1. But dimensionally, velocity, the unit for velocity now, dimensionally, velocity becomes, this m is meter. It becomes L. You change to L. Slash, the time in seconds change to what? T. So this dimensional analysis is all about you come and be changing. You come and change the mass. Anytime you see the mass, you change it to m. Anytime you see the length, which is m, you change it to L, and the time, which is S, you change it to what? T. That is what you need to know about dimensional analysis. If I say what is the dimensional unit for acceleration? acceleration. Acceleration is velocity over time. So since acceleration is velocity over time, and velocity is measured in meter per second, that is meter divided by second, then over time again, and that time is measured in what? Second. Look at what we are doing now. So what would now be, our acceleration becomes m over s times, this is the same thing as dividing by 1 over what? S. Everything giving you m divided by s square, giving you meter per second square. Meter per second square. So that meter per second square you normally hear or see, that is how we derive it. Is it clear? Yeah. But dimensionally, m is, for the length, m is what? L. Then for the time, s is what? T. We put our square there. This becomes the dimensional unit for acceleration. This is the derived unit for acceleration, and this is called the dimensional unit for acceleration. So let's go further. If I said force, the dimensional unit for force is equal to mass times acceleration. Mass is measured in kilogram, acceleration is measured in meter per second square. So this is kilogram times meter. This per second square is the same thing as dividing s square here. So everything will now give you, what will everything give us? Everything will now be, for kilogram, what do we have there? Represented by what? For kilogram is represented by m, so we have m here, times for meter, m is represented by L, so we have L there, divided by, for second is represented by T, so we have T squared there. So everything become m L per T square. Sometimes you see something like this, m L T raised to power minus 2. So whichever way you see it in your textbook, it's correct. So this is called dimensional analysis. Introduction to dimensional analysis. So as a form of assignment, you have to do the assignment and drop the answer in the comment section. Do well to subscribe to my YouTube channel. Invite your friends to follow my Facebook page and my YouTube channel for more videos and interesting things on science subjects. So in this now, the assignment is you're going to derive or find the dimensional unit for density. Density is mass per unit volume. Mass divided by volume. So then pressure. You find the dimensional unit for what? Pressure. So with that, you can drop the answer in the comment section. Ask yourself the definition of pressure. I wouldn't tell you that. The definition of pressure. From the definition of pressure and the formula for pressure, you can derive the dimensional unit for pressure. Thank you for staying with us to the end of the video. Subscribe to my YouTube channel, share this video, and God bless you.